Alright, so this is 4.1 Lesson 2, the three types of solutions for a system of equations. Now, let's get the vocabulary done first. There is consistent system, inconsistent system, and a dependent system. A consistent system is going to have one solution. Alright, it's kind of the go-to thing, and it's what you expect is going to happen when you have a system of equations. In general, if you have your x, y, and we're going to graph the first line, we're going to graph the second line, wherever they cross, that one point is the one solution, alright, and we call it a consistent system because it's what we expect. Now, other things which can help out here, right off the bat we know that the slope of our first equation, I'm going to call it m1, and we're going to compare it to our second slope from our second one. These do not equal each other. So if you have different slopes, you will have a single solution. Now, the next vocab word, inconsistent, well, this is when you have no solution to your system. Now, if I were to graph these, this is when you end up with one equation and a second equation that's parallel to it. But not only is it parallel to it, you'll notice that their intercept points, where they cross the y-axis, are not the same. But because they're parallel, I know that their slopes are the same. In other words, m1 will equal m2, but b1 will not equal b2. This is why we did the review of the graphing chapter before we did the systems chapter. Now, if these lines are parallel, they will never cross, and otherwise there will never be a solution. No solution. Alright, finally we have what's known as a dependent system, and this textbook uses something a little bit different from this, and I'll explain the difference in a second. Now, when you have a dependent solution, you have infinite solutions. Now, the thing is, it's a dependent system. Now, what that looks like is this. I have my first equation, and then I have my second equation goes along the exact same line. In fact, what ends up happening is they are the same line. Alright, your slopes and your intercepts will equal each other. Alright, so if your slopes and your intercepts equal each other, it's the same darned line. Now, what your homework says when you have an infinite solution system, it says it has a set bracket, it has the x comma y, such that that's that vertical line, and then it says the one equation. And it'll write it either in standard form or it'll write it in y equals mx plus b form. So it might be 2x minus y equals 3. Okay, that's because if you worked out the two equations, what ends up happening is you only get one equation because they're the same. Now, here's some clues that this is going to happen. Now, in the next videos, I'm going to talk in 4.2 and 4.3 about getting solutions. But if you're working on a problem, right, and no matter how you're working it out, if you end up with an impossibility like 1 is equal to 2, alright, that means you have an inconsistent system. That means there is no answer. If you end up with, while you're working out your problem, and you're not graphing it, but you're using one of the other systems like substitution or elimination method, you end up with something like 1 equals 1, that's always true, then you know you have infinite solutions. If you end up with 1 equals 2, you have no solutions. Otherwise, you'll just end up with like x equals 2, and then you plug it back in to get y equals something, whatever it is, like 3. Okay. So, those are the three types of systems that you run across. Consistent for one solution, you get an x and a y value. You get that one point where they cross. Inconsistent, you end up with parallel lines, so the slopes are the same, but the intercepts are different. And if you're working it out algebraically, which we'll do in the next videos, you end up with something like 1 equals 2. You get an impossibility, you get an absurdity. Last but not least, a dependent system is when your slopes are the same and your intercepts are the same. In other words, you have the same line. When you're working it out algebraically, you end up with 1 equals 1, something that's true. And what our text is having us get out of it is they want us actually to recognize whatever that one equation is that they both are.